about the words discrete and continuous, but you might not remember. I'll refresh your memory today. So, just in general, let's match. What does dependent go with? Dependent goes with the y. Independent goes with the x. What about output? What does that go with?
Y.
That goes with the y. And input goes with the x. Discrete and continuous are just two separate things all on their own. And they have to do with if the graph is made up of dots, then it's discrete, and if it's made up of smooth like lines and curves, then it's continuous. That's all that has to do with, and I'll show you that when we get to it in the problems. All right, so let's fill in the blank. Domain is all the x values. It is the independent variable. It is also the input of a function. Range is the y values. It is the dependent variable. It is also the output. And so you might see those things interchangeably. Sometimes I put x, y. Sometimes I put input, output. And sometimes I think you've even seen on some of our mapping diagrams I had independent and dependent. So we learned with the restaurant functions yesterday, there were different ways I was going to show you functions, right? Ordered pairs, tables, mapping diagrams, graphs. So kind of keep, that would be like a graph of points would be a scatter plot. But sometimes, Ben, the graphs will be like some of the ones in the opener where we had like that oval shaped, okay? So we're going to look at all of those different ways today on how you find domain and range. The very first one we're going to talk about is if we see a discrete function. A discrete function just means that you have points that are not connected to each other. So like this. Do you remember how I had you plot that one in the opener today? Okay, not connected. When that is the case, very simply, you did this yesterday in Joey's relations and functions, you literally list all of the x's and you list all of the y's. So for instance, for this function, 0, 2, 1, negative 5, 2, 8, 3, 10, the domain, notice how I listed it with the bracket is 0, 1, 2, 3. It's all of the x values in order. Okay? And the range, what's the range?
2, negative 5.
Yeah, it's all of the y values in order. Okay. Let's look at, we'll just look at the one right here. We're not going to go on the previous page. This mapping diagram up here, can you tell me what would the, you can't see it, what would the domain be for that one? 0, 1, 3, 9. So the way we'd write it is 0, 1, 3, 9. D stands for domain. How would you write the range?
Negative 5, 4, 8, 14.
Negative 5, 4, 8, 14. Okay. So that's all you have to do when you're given discrete data. That means stuff in a mapping diagram, a table, or just, I might just give you the ordered pairs. Okay. Since these functions are all discrete, they are just specific points, not continuous lines, we have to list them out. So there's kind of two categories today. This is how you do domain and range if you just are given the points. The second thing we're going to talk about is how do you describe the domain and range if it's a graph that's smooth and connected? Because there's no way in the world you could ever list every single point. Okay. You ready for me to flip, or do you need a second? It's okay if you need a second. Need that enough? Okay. Okay, below here, these are called continuous functions. So continuous function is different because it's a smooth line or curve. So do you see, this is a line segment here. It starts here and it ends there, okay? That making sense between discrete and continuous? Unfortunately, there's no way in the world you could list every single point on this line, because there's not just ones on every whole number, like there's one right there, and there's one in between there, and there's actually an infinite number of points, because you could go teeny tiny. So we have to describe the values in a different way. We can't list them out, and the way we describe them is we say, where does the x value start? Think all the way, what's the furthest it goes to the left, and what's the furthest it goes to the right. So let's look here. I'm just going to try on the graph. Think of the x values now, okay? What's the furthest x value on the left? The furthest x value.
Oh.
Like what's this is the furthest this graph goes to the left.
Oh.
Its coordinates are -7, -3.
Yeah.
So the furthest it goes to the left is -7. We're looking at domain right now. What's the furthest this goes to the right? 4. So if I wanted to describe those x values, I would say they go from -7 to 4. So the way that I write that as a inequality is the domain goes from -7, do you see, less than or equal to x, less than or equal to 4. That just means that x is including and between -7 and 4. You're going to learn to write this part in a little bit. Okay. So when I'm thinking left to right, that's, remember, domain. All right, let's change our perspective now. Range is y values, right? So instead of left to right, let's go from bottom to top now. Now I want to describe the y values. So I'm going to still write the ordered pairs, but I'm going to pay attention to the y values. So this is still -7, -3, but what I'm looking at is the lowest y value. The lowest y value is -3. Up here, what's the highest y value? Hold on, I think isn't it 7? So really, so this graph, isn't that the ordered pair 4, 7?
No, it's 4. You mean from the last?
No, what's this ordered pair that I'm pointing to?
Oh, yeah, 4, 7.
4, 7. Okay. So I want to know what's the lowest y value and what's the highest y value on that graph. What's the lowest y value? Say it louder. -3. What's the highest y value? 7. So the range goes from -3, less than or equal to y, because I'm describing the y coordinates, all the way to 7.
Wait, on the last graph, why did you say 4 and 5? Like, why isn't it the same thing?
Okay, so this graph is domain. What does domain explain?
Oh, no, never mind. That was my bad. I accidentally put.
You plotted this wrong?
Yeah.
Okay. All right, so just make sure you're going really slow and carefully. Domain, you're doing x's left to right. Range, you're doing y's. Okay. Look down at the bottom. What do you notice is a little different on that graph? There's one little difference.
The white circle.
The open circle
Yeah.
And it's going down instead of up. Okay. So, do you remember in the opener today, I said, what does an open circle on a graph mean? It goes close to but never gets there. So, we use these symbols for an open circle. So, the only difference when you're doing domain and range is you're going to use a different equality symbol because it doesn't equal it, it just goes up to it. Okay? All right, let's write our ordered pairs. What's that ordered pair? -6, 4. And this one, we're going to just be careful. It's open, but if it were going through, this one is 6, -6, isn't it? Would you highlight or underline the x coordinates?
Please receive an option. The athletic council that sends to Oak College is doing this at this time. Thank you.
Okay, so let's describe this with an inequality. The x values go from what to what? -6 to 6. So the way I write domain is I write -6 less than or equal to x. And then I write less than 6. They're in Mrs. McDonald's. Yeah. Okay, did you make sure that this inequality doesn't have an or equal to under it? Okay, good. Now let's, I had you underline last time, right? Would you circle or highlight in a different color the y's? Okay. So range, we go from the bottom to the top. What's the lowest y value you see? The lowest y value you see? -6, and it doesn't include it, right? And the highest y value we see is 4. So we would write -6. I write a less than symbol because it does not, okay? Y, and then less than or equal to 4. What that statement means is y is bigger than -6 and less than or including 4. That's all that means. Okay. Couple more. What does an arrow at the end of the graph mean? It goes forever and ever and ever. And think of Buzz Lightyear, Frank. Think of Buzz Lightyear when you see those arrows. To infinity and beyond. Yes. Okay. So if their arrow's up, it's infinity and beyond. If their arrow's down or to the left, it's negative infinity and beyond. Okay. So if this goes forever to the left and right, I can't tell where the graph begins and ends. So here's what I write. The domain goes from negative infinity to infinity. So if you see arrows going to the left and the right, that's what that means. Okay, how would I write the range? The range, you could say, is less than or equal to 4, or I have some students to keep the same way. They say, well, it goes down to negative infinity, but then the highest point it goes is 4. So that's you can write it either way. Is it continuous or discrete?
That one there.
Yeah. Continuous, smooth curve. Yep. Okay. If you're unsure if there are arrows on the end of a graph, would you just ask me? This graph stops. I'm going to put the dots here. Would you write the ordered pairs on these? And would you try the domain and range on your own?
Wait, so for the range, the lowest one goes first, but for the domain, the highest one goes first?
Mm-mm.
That's what you did on this one.
So domain is left It's different, left to right,
Oh, okay.
okay?
Yeah.
So that's where, you have to kind of put different hats on.
Yeah.
And range is bottom to top.
Okay, that makes sense.
But those are good questions. Because I looked at different ordered pairs because I was looking for a
Yeah, I
different
was-
thing.
Yeah. Okay.
I'm going to highlight my X's in orange and my Y's oops. That doesn't help me, does it? Because I have to go up here. I have to put the highest point on here. Because I got to go bottom to top. Okay. Now this graph isn't aligned, so it goes up too. So let's just think left to right. What's the furthest X value this goes to the left? -5. And it goes up, but I'm not looking at up and down right now. What's the furthest this graph goes to the right? 5, and they're closed circles. So for your domain, you should write -5 less than or equal to X less than or equal to 5. Now I put my pencil down here, and now I'm going to look bottom to top. And I'm going to look at the Y values. What's the lowest this goes? 0. And what's the highest this goes? 5. So I write 0 less than or equal to Y less than or equal to 5. Are we doing okay? Okay. Let's try one of these. We'll pick one on each page to do together. I'll let you pick.